So let's look at one more example problem where we're using factorization of polynomials with substitution. And remember our two formulas we're using for perfect squares and differences of squares. We're essentially trying to recognize those patterns in the polynomial so that we can factor it a little bit easier. So let's first rewrite this expression. We have x minus 3 to the second minus 64y to the fourth. And this problem tells us that we can factor the expression as u plus v times u minus v, which you might recognize is our difference of squares. Since notice we have some expression, some term here squared, and we're subtracting some other term that can also be written as a square. Since 64 is really just 8 squared, and y to the fourth is really just y squared squared. So to answer this problem, we just need to recognize what u and v are from our formula, and then actually factor the expression. So we can notice that we have x minus 3 squared. So our u value in our difference of squares formula, u is just x minus 3. And for v, we're subtracting some other square. Notice that we just really need to find the square root of this number. Since we've already recognized that it is a square, now if we take its square root, the square root of 64, that's just 8. And the square root of y to the fourth is just y squared. Since think about it, if you were to square this, you would get 8 times 8, which is 64. And y squared times y squared is 4 y's multiplied together, so that's the same thing as y to the fourth. So let's now just rewrite it using our formula. So we have u squared, that's our x minus 3 squared. That's already written as it should be for the formula. And we're subtracting 8y squared squared. And to compare it to our formula, remember it's the first term minus the second term, ignoring the squares. So we have x minus 3. Let me rewrite that 3. So x minus 3, and we're subtracting or adding, it doesn't matter. So it's the first one minus the second one, 8y squared, and again, you're ignoring the squares now, multiplied by the first one plus the second one. So x minus 3 plus 8y squared. And this is what we think is our answer, but to know for sure, we would actually need to multiply this out. So we can check this with just distribution. So let's quickly do that, just so that we can feel certain that we're doing this correctly. So the x minus 3 distributes to both. So x minus 3 times x minus 3 is just x minus 3 squared. And then x minus 3 times 8y squared will just be 8y squared times x minus 3. And then we get minus 8y squared times x minus 3. So these middle terms are going to cancel out, which is what we'd expect here. And then we get minus 8y squared. We're now distributing this like we did in the last one. So minus 8y squared times 8y squared, that is minus, let me make just a bit of room here. 8 times 8 is 64, and y squared times y squared is y to the fourth power. So again, notice these middle terms, 8y squared times x minus 3, will cancel out since we have a positive version and we're subtracting the same term from that. So this and this cancel out, and we just get x minus 3 squared minus 64y to the fourth. And since that's what we started with, we know for sure that this is the correct answer here.